Welcome back to Omni Eyes. Today we dive deep into the ocean to uncover a fascinating master of advanced optical engineering. Have you ever felt completely frustrated when taking a photograph that ends up entirely overexposed or totally lost in deep shadows? Human cameras constantly struggle with extreme lighting conditions, failing to capture intricate details when bright sunlight and dark shadows mix together. Photographers often spend countless hours adjusting complex settings just to balance the light and dark areas within a single, beautiful frame. But nature has already solved this complex problem millions of years ago, hidden beneath the waves in a truly alien creature. Meet the incredible cuttlefish, a highly intelligent marine animal possessing an extraordinary visual system that completely defies our modern technological limitations. If you look closely at their fascinating eyes, you will immediately notice a very strange and highly distinct W-shaped pupil. This unusual W shape is definitely not a random evolutionary accident, but rather a highly sophisticated optical design for light control. The unique pupil acts as an advanced biological filter, precisely managing the sheer volume of light entering the sensitive retina behind. In shallow waters, bright sunlight penetrates from above, creating a chaotic environment filled with blinding reflections and extremely dark, confusing shadows. A perfectly round pupil would let in too much intense overhead light, causing the animal to be completely blinded by glare. The clever W shape physically blocks the harsh downward sunlight, while simultaneously allowing softer ambient light from the ocean floor inside. This brilliant mechanism allows the cuttlefish to maintain absolute control over visual contrast across completely different sections of its complex retina. Because of this, the creature can clearly see minute details even when navigating through environments filled with incredibly chaotic light patterns. In the modern world of digital photography, we refer to this exact capability as high dynamic range, or simply HDR technology. To achieve HDR, our cameras usually must capture multiple separate images at different exposures and digitally stitch them together very slowly. The cuttlefish, however, performs this exact same sophisticated contrast balancing act instantaneously, using only the physical structure of its remarkable eye. It is never blinded by the glaring afternoon sun, nor does it lose crucial visual information when hiding in dark shadows. Imagine the immense evolutionary advantage this provides when hunting elusive prey or actively avoiding dangerous predators in complex coral reef ecosystems. While other marine animals struggle to see through the dappled light, the cuttlefish experiences a perfectly balanced, crystal-clear visual field. This biological marvel has recently caught the intense attention of optical engineers and scientists, seeking to revolutionize our modern camera technology. Current security cameras often fail miserably when placed in environments experiencing extreme lighting differences, like dark tunnels facing bright outdoor sunlight. A surveillance system equipped with a W-shaped lens aperture could automatically balance light exposure without requiring any heavy digital processing. This innovative biological design would represent a massive leap forward for security cameras operating in locations with highly unpredictable lighting conditions. Autonomous vehicles also desperately need better vision systems to safely navigate urban streets during challenging sunsets or sudden blinding headlight glare. By mimicking the cuttlefish, self-driving cars could maintain perfect visual awareness, preventing tragic accidents caused by momentary blindness from light. The secret lies in the precise geometry of the W curve, which mathematically optimizes light distribution across the underlying electronic sensor. Researchers are currently developing artificial lenses that dynamically change their shape, perfectly copying the muscular movements of the living cuttlefish eye. These smart lenses can instantly adapt to shifting light conditions, ensuring that every single captured frame retains maximum detail and clarity. It is truly astonishing how an ancient cephalopod holds the ultimate blueprint for solving one of our most frustrating modern problems. Let us take a closer look at the cellular structure of this eye to truly appreciate the genius of underwater evolution. Unlike human eyes, which have a single focal point, the cuttlefish eye contains a highly specialized retina packed with unique photoreceptors. These specialized receptors are densely arranged in a specific curve, allowing the animal to focus on multiple different distances, all simultaneously. This means the creature does not need to constantly change the shape of its lens to track fast-moving prey underwater. Furthermore, cuttlefish are actually completely colorblind, seeing the entire vibrant underwater world in varying shades of black, white, and subtle gray. You might think being colorblind is a severe disadvantage, but it actually allows them to process pure contrast with unmatched speed. By completely ignoring distracting color information, their brains dedicate all processing power to detecting subtle variations in light intensity and polarization. They can literally see the polarization of light, a hidden dimension of vision that remains entirely invisible to the human eye. This polarized vision helps them easily spot transparent prey, like tiny shrimp, which would otherwise perfectly blend into the surrounding water. The W-shaped pupil perfectly complements this polarized vision, acting as a directional shield that filters out scattered, confusing light waves. When a cuttlefish feels threatened, it can rapidly adjust the size of this W shape, instantly modifying its visual input defense. In near total darkness, the pupil opens up completely, transforming into a large circle to gather every single available stray photon. But the moment bright light returns, the muscle contracts instantly, forming that iconic W shape to protect the sensitive retina behind. This dynamic mechanical response is significantly faster and far more efficient than the iris contraction found in the standard human eye. We are only just beginning to unlock the profound mysteries hidden within the complex nervous system of these fascinating marine creatures. Building an artificial camera that truly replicates this level of biological perfection requires groundbreaking advancements in material science and microengineering. Engineers are experimenting with flexible polymers that can instantly change their opacity and shape when a tiny electrical current is applied. These advanced synthetic materials could eventually replace the rigid glass lenses and mechanical apertures currently used in our expensive photography equipment. Imagine a smartphone camera that never requires a flash and never produces a washed-out image, regardless of where you point. You could take a perfect portrait of a friend standing directly in front of a blazing sun, without losing any details. This level of seamless optical performance would completely transform how we document our daily lives and capture our most precious memories. Beyond consumer photography, the military is also highly interested in developing surveillance drones equipped with these advanced biologically inspired visual sensors. A drone flying through rapidly changing weather conditions needs to maintain continuous, uninterrupted visual contact with its designated targets below ground. The cuttlefish eye provides the exact mathematical model needed to build these highly resilient, next-generation optical sensors for aerial reconnaissance. It is a beautiful irony that a soft-bodied creature from the ocean depths is inspiring the future of aerospace technology. Nature operates as the ultimate research and development laboratory, conducting countless evolutionary experiments over the span of hundreds of millions of years. Every single physical adaptation we observe in the wild represents a perfectly optimized solution to a highly specific environmental survival challenge. By humbly studying these natural solutions, human scientists can easily bypass decades of frustrating trial and error in their own laboratories. The field of biomimicry is rapidly expanding, bridging the massive gap between biology and cutting-edge mechanical engineering in remarkable ways. As we continue to explore the vast, uncharted oceans, we will undoubtedly discover even more incredible creatures with unimaginable biological technologies. The ocean remains our planet's greatest unexplored frontier, holding countless secrets that could profoundly revolutionize our understanding of science and physics. Think about the sheer complexity of the cuttlefish brain, which must process all this high-definition, polarized data in real time. Their brains are surprisingly large for invertebrates, featuring massive optic lobes completely dedicated to decoding the complex signals from their eyes. This immense processing power allows them to instantly change their skin texture and color to perfectly match their surrounding underwater environment. They use their incredible vision to carefully analyze the seafloor and then project that exact pattern onto their own skin. It is the ultimate biological cloaking device, driven entirely by the flawless visual data collected through their W-shaped optical sensors. Without their perfectly balanced HDR vision, their incredible camouflage abilities would be completely useless in the chaotic lighting of the reef. They must see the world with absolute clarity in order to successfully deceive the eyes of both their predators and prey. This intricate dance of light, vision, and survival showcases the breathtaking elegance of evolutionary design in the unforgiving deep blue sea. Every time you use the HDR mode on your modern smartphone, Take a brief moment to remember the brilliant little cuttlefish. We are currently relying on heavy digital software to artificially recreate what this incredible animal does naturally through pure physical geometry. The future of optical technology will likely move away from heavy digital processing and return to elegant, physically optimized lens designs. By integrating biological principles into our hardware, we can create devices that are significantly faster, highly efficient, and much more reliable. Imagine security cameras that never require external power to adjust their exposure, relying solely on smart, light-reactive materials from nature. These self-adjusting systems could be deployed in remote wilderness areas, continuously monitoring endangered wildlife without ever missing a crucial moment. Environmental scientists could use these cameras to study nocturnal animal behavior during the tricky transition periods of early dawn and dusk. The applications for this bio-inspired technology are truly limitless, spanning across multiple industries, from consumer electronics to advanced space exploration. Even space telescopes could potentially benefit from dynamic aperture designs that automatically block out the blinding glare of distant, burning stars. This would allow astronomers to clearly capture the incredibly faint light reflecting off small planets hidden deep within those star systems. The microscopic structure of a marine animal eye might literally help us discover new habitable worlds hidden across the vast universe. It is a profound reminder that the answers to our biggest cosmic questions might be swimming right here in our oceans. We must fiercely protect these fragile marine ecosystems, because every species we lose takes a library of evolutionary knowledge with it. The cuttlefish is just one single example of the countless biological wonders that are currently threatened by rapid climate change effects. Ocean acidification and rising global temperatures are slowly destroying the vibrant coral reefs where these magnificent masters of light currently reside. If we allow these delicate habitats to completely disappear, we will lose priceless biological blueprints that could dramatically improve our future. Conservation is not just about saving beautiful animals. It is about preserving the greatest technological archive that has ever existed anywhere. We have a profound ethical responsibility to ensure that future generations of scientists can continue to study and learn from nature. The story of the cuttlefish eye perfectly illustrates the incredible power of interdisciplinary science, bringing biologists and engineers together in harmony. When we combine deep biological observation with advanced mechanical engineering, the resulting technological innovations are consistently spectacular and truly world-changing. As you walk through the world today, pay close attention to the complex interactions between bright light and dark, heavy shadows. Notice how your own human eyes struggle to rapidly adjust when stepping out from a dark building into the bright sunshine. Appreciate the immense difficulty of capturing that dynamic visual experience and marvel at the tiny creature that has completely mastered it. The W-shaped pupil is a masterful stroke of evolutionary genius, a tiny biological window into the complex physics of light. It stands as a powerful testament to the relentless ingenuity of life, constantly finding brilliant ways to overcome harsh environmental obstacles. Our journey into the depths of biomimicry is just beginning, and the cuttlefish has provided us with a truly illuminating spark. We will continue to explore these fascinating connections between the natural world and human innovation in future episodes of this series. There are still so many incredible biological mysteries waiting to be uncovered, decoded, and transformed into revolutionary new human technological advancements. From the deepest, darkest ocean trenches to the highest mountain peaks, nature's brilliant engineering is constantly on display for our education. We simply need to open our minds, look very closely, and possess the humility to learn from the creatures around us. Thank you for joining us on this deep dive into the fascinating world of the cuttlefish and its incredible HDR vision. We hope you now have a profound new appreciation for the brilliant optical engineering hidden within the mysterious deep blue sea. If you enjoyed this fascinating exploration of nature's technology, please remember to like this video and share it with your friends. Make sure to subscribe to our channel so you never miss another exciting episode detailing the hidden wonders of our world. We are dedicated to bringing you the most captivating stories where biological science and modern technology intersect in truly beautiful ways. Until next time, keep exploring, keep questioning, and always remember to look closer at the world. Goodbye from Omni Eyes, everyone.